Now in this chapter we are going to learn the concept of current electricity. So first we should know the sources of direct current. We have two kind of cells which are the sources of direct current. First is primary cell, second is secondary cell or accumulators. Here is the diagram. This is the diagram for primary cell, this is the diagram for secondary cell or accumulators. Then we have differences between primary cells and the secondary cell. Primary cell is basically the cell where chemical reaction is irreversible, but in the secondary cell, chemical reaction is reversible. In the primary cell, chemical energy is converted into electrical energy when current is drawn from it, but in the secondary cell, electrical energy is converted into chemical energy when current is passed in it. Primary cell cannot be charged, but secondary cell can be charged. In the primary cell, internal resistance is very high, but in the secondary cell, the internal resistance is very low. Primary cell, it is capable of giving weak current only, and secondary cell can provide low as well as high current. Primary cell is very light and cheap, while secondary cell is very expensive. For example, we have primary cells of different kind like simple voltaic cell, Lagrange cell, Daniell cell, dry cell, and for secondary cell we have also multiple examples like lead accumulator, Nephi accumulator. Then we have electric current. Current is basically the rate of flow of charge across a cross section normal to direction of flow of current. This is basically the diagram of electric circuit. Current is basically charge per time and its SI unit is ampere. Current is a scalar quantity. Now we have symbols used in circuit diagram. This is very important because in exams you have to draw the diagrams as well. So for the source of current, we have multiple sources. First is alternate source, or second is direct source such as cell or battery. For the cell, this symbol is used. For the battery, this symbol is used. For the AC source, alternating current, this symbol is used. Now next diagram for the key, for the switch. When the key is open, you have to make diagram like this. When the key is closed, you have to make diagram like this. Resistance wire, resistance box, rheostat and variable resistance. To denote them, you have to make diagram like this. Linked wire. Then we have ammeter. Ammeter is an instrument used to measure the magnitude of current flowing in a circuit. This is how we make the diagram of ammeter. Then we have voltmeter. Voltmeter is used to measure the potential difference between 2 points of a circuit, and this is how the symbol of a voltmeter looks like. Then we have galvanometer. It is used when we want to detect the presence of very weak current in an electric circuit, and this is how the symbol of galvanometer looks like. Then we have load. It is basically an appliance which is connected in a circuit. So this is the diagram of load. Then we have connecting wires. These are the wires used to connect various electrical components. This is basically a straight line. Then we have simple electric circuit. This is basically the combination of resistance, the combination of cell, ammeter, voltmeter, and this is how the electric circuit is drawn. You must practice the diagram of simple electric circuit, the open circuit and the closed circuit. Then we have insulators and conductors. Insulators are those substances which do not allow current to flow through them. They are plastic, they are wood, they are paper, they are glass, leather, etc. They have almost no free electrons and offer a very high resistance to the flow of current, while the conductors are those substances which allow current to flow through them very easily. And for example, some of the conductors can be copper, aluminium, silver, iron, brass, etc. They have a large number of free electrons and they offer a very small resistance to the flow of current. And now we are going to learn the concept of resistance in the later part of this chapter. Closed and open circuit. This is the closed circuit. The wires are closely connected to the cell and the bulb. This is the open circuit where wires are closely connected to the cell but they are not connected to the bulb from both the ends. So bulb is not blowing here because there is not continuous flow of current. The path along which current flows is called a circuit. The current flows when the circuit is closed. The circuit is said to be closed when the key in the circuit is closed. When the key in the circuit is open, circuit is said to be open, and in this state the current does not flow in the circuit. Flow of the electrons between the conductors. Electrons move from the uncharged conductors B to the charged conductors A to balance the deficit of electrons in the conductor A. This movement of electrons continues till both the conductors have an equal charge. Electrons flow from the negatively charged conductor A to the uncharged conductor B. This movement of electrons stops when both the conductors acquire an equal charge. Electrons flow from negatively charged conductor A to the positively charged conductor B. This flow of electrons continues till there is an equal charge in both the conductors. Direction of the electric current, conventional and electronic flow. The electric current is said to flow from a body at higher potential to a body at lower potential, that is, in a direction opposite to the direction of flow of electrons. Thus, the direction of flow of conventional current is opposite to the direction of flow of electrons. Here is how the flow of electron is, and here is how the flow of current is. Both are opposite to each other. Now, work done in transferring charge through a conducting wire. Potential difference is basically work done in transferring a unit positive charge from one conductor to another conductor. The formula for potential difference will be W by Q, and the SI unit of potential difference is volt, and it is denoted by capital V. Potential difference between 2 points is said to be 1 volt if work done in transferring 1 coulomb of charge from one point to other point is 1 joule. Now, electrical resistance. The obstructions offered to the flow of current by a conductor is called the electrical resistance. As per Ohm's law, it states that current flowing through a conductor is directly proportional to the potential difference applied across its ends, provided its temperature is constant. That is, I is directly proportional to V, V is directly proportional to I, or V equals to IR when R is the resistance of conductor. Then unit of resistance. So this is basically the symbol of resistance. This is omega, and the formula for calculating resistance is V by I, R equals to V by I. The resistance of a conductor is said to be 1 ohm if a current of 1 ampere flows through it when the potential difference across its end is 1 volt. Factors affecting the resistance of a conductor. First is the material of wire. Good conductors having higher concentration of free electrons and offer less resistance. Second, the length of wire. The longer wire offers higher resistance than shorter wires. Area of cross section of wire. A thick wire offers less resistance. Then the temperature of the wire. The resistance of wire increases with the increase in temperature. So that's all in this chapter. See you in the next chapter.